Okay, so what the hell is happening right now? There's a solar eclipse on the way. There's lightning striking the Statue of Liberty, which might actually be the statue of some devil worship thing. And then there's an earthquake, multiple earthquakes. Earthquake happened in Taiwan, which kind of rarely happens, doesn't happen often, and then all of a sudden it happens again in New York. And the epicenter of that earthquake was on a Trump golf course property where one of his wives are buried. It's just, they all seem super fake. They all seem unrelated, but they're real. If you look at the interstate going from Long Island to New York right now, it's just jam-packed. It's bumper to bumper, and it's packed because everyone's trying to get out of Long Island and get into New York so that they could go somewhere else that's not an island. So do these lightnings, do these earthquakes, and does the solar eclipse have anything to do with each other? The answer is, and could this be a man-made military weapon that was kind of just tested out a little bit, kind of like the way they tested out the first nuclear weapon in the United States in the Southwest, and then they decided to test it in Japan and in real life with real humans. Did they test some kind of superpower military weapon that can cause earthquakes in Taiwan, and then now in New York with the epicenter in a Trump property on a year when Trump is going to be elected? Who was it? Was it Lyndon Johnson? I think one of the presidents a long time ago, he said, in politics, if it looks like a coincidence, it's not a coincidence. And that's pretty much real. So how does all this stuff come to play? What will that do to the economy? What will that do to stocks? I'm going to answer that in this video. First of all, you have to understand what causes lightning, earthquakes, and everything else in the world. Everything in the world, even volcanoes, which I don't think there's been any volcanic eruptions so far, but there could be. Mark my words, there could be. I haven't done the calculations to know which part of the world will have a volcanic eruption, but I suppose I could and then do part 2 of this video. I'm going to do the calculations using futureview.app. So go to futureview.app, play with it, and it's macro and it's micro. It'll tell you what's going to happen in the world, it'll tell you what's going to happen in your life, and it can even tell you what's going to happen in your neighborhood. It's the weirdest thing. It's a prediction algorithm that I'm going to use to explain the relationships between the earthquake, the lightning, and the eclipse. Even volcanoes all happen because there's a pressure imbalance. There's an energy imbalance. One side of the energy in a system has more energy than the other side of the energy in the same system. Okay, what does that mean? If you ever rub your feet on a carpet, you notice nothing changes in your body. You rub your feet on the carpet, and nothing really changes until you touch another person, and then zap! If you've ever touched another person after rubbing the carpet in the dark, there's actually a real literal light spark. The air heats up so much that the oxygen molecules actually burn, and there's a literal visible light spark, like a strobe light or a flash pop that happens between you and the person you touch. Of course, if you touch something else like metal, or if you touch something else like water, you could get the same charge. But that's because as you rub the carpet, what's happening is you are adding more electrons to your body than the other person that's not rubbing their feet on. So the electrons go from your body, tons of electrons, overload, too much electron pressure. Oh, there's another person I can make contact with. Air is an insulator. So I can't get through this air until boop, I make contact. The moment I touch somebody else, all those electrons rush over instantly and flood over into the other person's body, which creates the shock, because the other person doesn't have as many electrons proportionally than you do. Okay? Now, you remember that. This is also exactly the same way volcanoes work. There's too much pressure in the earth and not enough pressure in the atmosphere, in the air. Normally what ends up happening is there's just enough air pressure and just enough land pressure to where the air pushes the land down and the land is just happy to stay down because gravity also pushes it down, pulls it down. But if there's more pressure underneath, then magma erupts, right? What does this have to do with the solar eclipse? Does a shadow on the ground have any energy? It can. A shadow on the ground can have temperature energy. Suddenly you're in the shadow, it's suddenly cold, right? But that's not the kind of energy that causes earthquakes. It's not strong enough. I suppose if it was super, super cold, and it created a super, super cold zone on the earth itself, it could create an earthquake, but it would have to be pretty darn cold. In this case, why on earth would an eclipse have anything to do with an earthquake and the lightning on the Statue of Liberty? When you have an eclipse, what's actually happening is that the sun is here and the moon is here and the earth is here. So literally they all line up, right? What happens when the moon is directly overhead and you're on the beach? What happens? When the moon is directly over, oh, there's the moon and here's the beach. Holy shit, that tide's gonna swallow me up. You get a rip tide, you get high tide. Only the best surfers can surf those tides because there's so much energy in the ocean because of the gravity from the moon. What happens if the moon and the sun line up? Oh, I don't know. Okay, so maybe the moon's gravity affects the tides and makes high tide, but the sun's gravity doesn't exist. Really? There's actually people that think that the sun doesn't have any gravity. If you take the sun's gravity, which always, always, always exerts a slightly variable pressure on the earth, and you multiply that by the moon's gravity, boop, what ends up happening is that it's kind of like taking the sunlight that comes from the sun and hits the earth, and then you take a magnifying glass. Have you ever tried that with your grandfather's magnifying glass? And just kind of put it right between the sun and a piece of paper and focus the sunlight. Just focus the sunlight on this piece of paper. The piece of paper burns. It just burns to death. That's because you're focusing the energy of the sun's light onto paper. You're focusing the sun's heat onto paper. But what if the moon gets between the sun and the earth? The moon has gravity, the earth has gravity, and the sun has gravity. All three of those factors, you put them together, and the moon acts just like that magnifying glass that focuses the gravity of the sun onto the earth. Now, wherever that solar eclipse goes, wherever that shadow of the solar eclipse goes, right around there's a halo of super, super high gravity. Super, super. If it was higher, if it was much higher, let's say we amplify it 1,000 times or 10,000 times or whatever, it'd be like one of those UFO landing movies. Have you seen those UFO landing movies where UFOs land on the ground and suddenly rocks and stuff and everything starts to levitate? It'd be like that. Not only would the tides, would there be high tide, there'd be extremely high tides. All the lakes and all the rivers and stuff in wherever. So it looks like the solar eclipse is going to go through from near Louisiana up to barely touching New York, Niagara Falls area. It's just going to go straight up the United States, kind of at a slight diagonal. From about Texas or Louisiana and go towards Niagara Falls area, kind of affecting the Great Lakes area. Wherever that goes, that's where the sun and the moon are aligned, and the moon is going to act like a magnifying glass and increase the gravity. So when you have Earth, you have tons of Earth, okay, just sitting there, and then you have this Earth in the center that's got super, super low gravity because the moon and the sun are both pulling at it. What ends up happening? Well, take your skin and just pull a certain part of your skin up. What ends up happening? if I were living on my skin right now, if I were living on the back of my hand, I would experience an earthquake. This is what an earthquake looks like. Now, if that happens, and you have the moon exerting gravity, extra gravity, from itself and from the sun onto the earth, would that cause a lightning storm? It actually could. It could actually cause a lightning storm in that, because there's extra gravity, there'd be a disparity between the gravity that's being... Think of gravity like a flashlight. It doesn't just cover everything like a puff of smoke or a bunch of powder. You see that, those, what is it, basketball? In basketball, they used to take chalk and throw it into the air and just everything covers everything. Gravity doesn't go everywhere. Gravity is directional, and gravity can be focused. When gravity is focused, and this, in the beam of gravity that's hitting the earth, from Louisiana to New York, right around that beam, if there's less pressure here and more pressure outside, what ends up happening? It's just like you rubbing your feet on the carpet. This air has more pressure than this air, and this air has more pressure than this air. Low pressure, high pressure, low pressure, high pressure, high pressure, high pressure, high pressure, high pressure. And this is where the solar eclipse is. The solar eclipse is happening here, and this is all the pressure differences between solar eclipse here and non-solar eclipse. Bright light, solar shadow, or lunar shadow, okay? So you're going to get all sorts of pressure differences from the gravity. So what happens when you get the pressure differences? Just like rubbing your feet on the carpet, it'll create a static difference. And when you have enough static difference, what ends up happening? You go poof, and this bright light supercharged poof explosion happens, which is actually lightning and thunder. But have past solar eclipses ever created earthquakes? Have past solar eclipses ever created lightning and thunder? Generally, no. Generally, no. They just kind of make a shadow go, and if that shadow happens to be in the ocean, well, you're not going to see it because it's in the ocean. But what ends up happening is there's this really cool stream, and it's called a tidal bulge. You can even look it up. And they call this particular bulge, super bulge of tides in water between the Earth, the Moon, and the Sun, a spring bulge. So you can look up spring bulge because it like compresses like a spring, boing, and just explodes. If it happens in the water, you wouldn't see it. If it happens on land, you wouldn't notice it unless there was an earthquake. So is it all natural? This isn't some military new heat power testing thing that they might have used to burn all of Maui? I didn't say that. If you were a scientist and you were in charge of building a weapon, some massive, super destructive weapon that could cause earthquakes, if you're going to do that, and you didn't have all the nuclear atomic power at your disposal, and you had to do it discreetly, because if you took too much power, well, everyone would kind of notice that the whole grid went out. Grid going out? Didn't that just happen? Didn't that just happen where an entire cellular network, what was it, T-Mobile in America, went out? I'm not connecting the dots for you guys. I'm not saying anything. But if you were a scientist and you needed to draw that much power, you would draw it off the grid and cellular networks would go down. And so you'd not be able to do that again without being detected, without being found out. So what would you do? You would choose a natural point of high leverage, a natural phenomena of high leverage to do this. What does that mean? Elon Musk is planning on sending people to Mars. Okay, here's the Earth, here's the Sun, and the Earth goes around the Sun. right? Now here's Mars. Mars is out here. Mars goes around the sun a lot slower. At some point, the Earth is going to be here, and Mars, which is farther away, this is the Earth's circle, Mars draws a huge round circle, right? So Mars is going to be way out here, and the Earth is going to be right here. It's super, super far away between Mars, and besides, the sun is in the way. If you tried to if you tried to go straight from the Earth to Mars, you'd run into the sun and get burnt out, right? But what if Mars was doing one of these things, and the Earth also happened to be doing one of these things, and the Earth was here, and Mars was right here? What if they were super, super close by instead of on the other side of the sun? And what if you could time that? If you could time that, what would happen is Earth would be coming up on Mars, like this. So this is Mars. And Earth would be, so let's put Mars here. Earth would be spinning around and coming towards where Mars is. And what you would do is you would launch here. You would launch the Elon Musk space rocket right now. And it would hit Mars because it's super close to each other in their own orbits. So you would time scientific endeavors to natural phenomena where the natural phenomena didn't require so much energy, or the planets were closer together, or the moon and the sun were lining up and giving you natural gravity that all you had to do is just barely, the tipping point, just barely push this over, just use a tiny amount of energy to push this over, and the entire set of dominoes would just go and crumble. If I was a scientist in charge of building a weapon that could cause massive earthquakes, that's what I would do. I would wait until the solar system itself created such a huge imbalance that all I'd have to do is just barely touch, and suddenly whole entire buildings would shake, and entire network infrastructures would go down. Did you know that? Did you know that the sun really does affect the Earth? Did you know that the sun actually affects computer systems and cellular systems? The sun itself, when there's a big solar flare, and if you're an if you're a fighter jet pilot in the sky during a solar storm, your instruments could actually go dark, and you could actually fall out of the sky and destroy $1 billion plane, a fighter jet. That's how much the sun affects us. You put that in line with the moon during an eclipse, and now you've multiplied that power. So what is that going to do to the financial markets? Well, any kind of instability always causes markets to crash. What will that do to Bitcoin? There will probably be an initial crash, because whenever stocks crash, and Bitcoin's super expensive, what ends up happening is people end up selling their Bitcoin to pay for their losses in the stock market. But in a condition like this where banks are closed on weekends, banks are closed at night, banks take 3 days to wire something, if Bitcoin does take a dip, it's a dip you want to buy because it's going to explode. It's an international currency that can't be stopped by banks. So if there is a big dip, which I'm expecting there will be soon. But keep in mind that Biden is going to want the stock market to be pumping right before the elections. So there might be a big dip and then another pump in the stock market as well. He's not going to try and get reelected when the stock market is at a 30% crash level, a 30% loss crash level. So down, then, and Bitcoin goes down, and then Bitcoin's going to go up first, and then stocks are going to slowly catch back up. That's what I expect to happen. And all these things are predictable because, well, the planets and the alignment of the planets and the stars, they're all predictable. They're all on really, really fixed routes around the sun or within our galaxy. What else is predictable? Everything is predictable. Everything is knowable. Even when you're going to get rich, even when you're going to get poor, is knowable. Even when you're going to find your soulmate, even who your soulmate is, when you're going to get a divorce, when you're going to get into a car accident, all these things, spooky enough, are predictable because everything is a waveform. Everything is energy. And energy is a wave. And waves have constant form. Anything with constant form is a pattern. Anything that's a pattern is predictable. So, everything is predictable. Find out when you're going to get rich. Find out when you're going to get poor. Find out when you're going to get lucky or unlucky or laid at futureview.app. Go there. Try it out. It's spooky. And get rich, guys.